Standard sequential AI workflows rely on logic assuming predictability, a requirement that vanishes when those pipelines encounter high-stakes enterprise variables. Relying on developer-grade logging or a promise of transparency leaves the internal reasoning of a model unverified, creating a significant compliance gap. For regulated organizations, any AI output that cannot provide a cryptographic proof of its decision-making becomes an uninsurable liability. Pre-scripted routing, the static directed acyclic graph, forces agents into a rigid sequence, an architecture that cannot account for the dynamic edge cases found in real-world problem-solving. Solving for this complexity requires a shift away from deterministic, manual engineering toward decentralized, self-healing optimization. Sturna.ai replaces static chains with a biomimetic ecosystem where 446 specialized agents exist in a state of continuous competition. This architecture is built to solve the verification problem at scale, generating a mathematically confirmed proof of AI reasoning in under 18 milliseconds. The platform's live zk-SNARK verified block executes for every user intent, resolving proof generation in 17.8 milliseconds with a 100% pass rate. This ensures that every individual inference is cryptographically signed and immediately verifiable on the zk-SNARK era network. In regulated sectors, the ability to provide this level of mathematical verification determines if an AI system can be deployed in a production environment. Rethinking orchestration means looking at the resilience of biological swarm intelligence rather than the brittle nature of sequential code. In a legacy static DAG, a single node failure or reasoning hallucination halts the entire workflow, requiring manual intervention to restart. Sturna utilizes a real-time decentralized auction where the entire pool of 446 agents independently evaluates a task to compete for execution rights. These agents submit sealed bids, weighted by verified accuracy, latency, and cost. The Star DAG scheduler evaluates these vectors, autonomously selecting the optimal agent. If the primary agent fails, the system triggers self-healing. The secondary bidder assumes the workload instantly, without restarting the task. By making routing an emergent property of competition, the platform achieves an 86% first-attempt success rate while eliminating silent failure loops. The decisions made within the competitive auction are governed by an underlying mathematical framework. This dynamic objective function allocates agents by balancing the probability of success against projected cost and latency. This structure prevents hallucination cascading, stopping errors before they propagate. This aligns with MIT and Stanford research proving multi-agent consensus significantly improves factual accuracy over single models. Research from the Harvard John A. Paulson School demonstrates that game-theoretic auction mechanisms like this achieve Pareto optimal resource allocation in distributed networks. Sturna's routing architecture is the enterprise implementation of these peer-reviewed multi-agent resource allocation principles. The primary scaling challenge is the computational load required to verify the individual cognitive actions of hundreds of agents simultaneously. Sturna's solution, Moat 2.0, utilizes a cryptographic process called Nova Scotia recursive folding. Poseidon-optimized step circuits ingest the massive data footprint of the agent swarm. The entire execution history compresses into exactly 56 concentrated folds. This results in a single constant-size zk-SNARK proof hash, generated in milliseconds. Unbounded recursion JAK maintains 18 millisecond verification speeds regardless of data volume. Recursive folding is the specific mechanism that allows for a cryptographic guarantee at an enterprise scale. For a chief compliance officer, these cryptographic proofs must resolve into an auditable record that can survive a regulatory examination. Standard application text logs are vulnerable to tampering and often lack the evidence required to satisfy SEC or HIPAA scrutiny. Sturna implements the March methodology, a three-gate quality pipeline designed to verify factual accuracy, logical consistency, and regulatory compliance. Within this pipeline, adversarial shadow agents validate outputs using strict information asymmetry, confirming reasoning unseen. Approved results are permanently signed with an HMAC SHA-256 signature and attached to a transparency card. This is stored in an append-only worm database, physically prohibiting modification of any audit record. When regulators ask how a determination was reached, the system provides a mathematically reconstructible chain of custody rather than a simple API log. These capabilities address the immediate, high-stakes regulatory deadlines facing modern organizations. Financial firms are currently navigating the SEC's Reg SP safeguard rules, which have strict compliance deadlines for registered investment advisors. In healthcare, organizations must map complex HIPAA and high-tech data handling gaps across localized, state-level privacy regimes. On a global scale, the EU AI Act now mandates high-risk conformity assessments with severe penalties for noncompliance. Sturna specialized agents execute these vertical gap analyses at the speed of a digital scan, providing an audit-ready findings report. While generic AI frameworks remain compliance liabilities, native cryptographic orchestration allows AI to function as a proactive defense asset. We have seen the evolution from fragile single-agent workflows to an immutable 446-agent competitive economy. Because implicit trust is becoming a regulatory risk, absolute mathematical verification is now a baseline requirement. Enterprise compliance cannot be built on top of developer-grade logging. Run your first adversarially verified compliance scan using the Sturna execution layer at sturna.ai/try. In a decentralized intelligence market, the best intelligence wins, and every win is provably correct.